This time we will see an example of kinematics of rigid body. It is example 4-1. Let us see this example first. It says an electric motor is rotating at 6000 rpm. rpm means revolution per minute. Revolution per minute. One revolution means one complete turn around an axis, and that means for every revolution it rotates 2 pi or 360 degree, 2 pi radian or 360 degree. Okay, when the switch is suddenly turned off, the fan decelerate at a constant rate and rest after 3 minutes. That means it was rotating at this speed, and then we turn off the switch and then it stopped in 3 minutes. What is mostly the angular deceleration? It is similar to linear problem, like a body is moving at 3 meter per second, a brake is applied, it is stopped after 3 minutes. What is the deceleration? Similar problem. Okay, so what is our initial velocity? Initial velocity can be found from this. What is your final velocity? Or this time it is angular, so final angular velocity is 0 because it rest after sometimes. That means final velocity, angular velocity is 0. Initial we can find from here. Now again, velocity or angular velocity is expressed in radian per minute or radian per second, whatever. It is not radian, it is revolution, so we have to convert it. So initial angular velocity is 608,000 revolution per minute, so revolution times 2 pi. That means every revolution it rotates twice pi, complete rotation. So total is 12,000 times pi radian per minute. And note down the unit of angular velocity. It is radian per minute, and that is my initial. Then what is my final? Final is 0. Final is 0 because it is stopping. What is my time? Time is 3 minutes. It is given 3 minutes. So, okay, then time is 3 minutes. If you convert your angular velocity in second, you have to convert the time in second. Then what is my equation? My equation is this equation, whatever equation we saw in the theory. It is similar to our equation that we commonly used for linear. For linear we use this equation, v equals v naught times at. We see this equation for our linear motion. This time we will use omega is omega naught plus alpha t. You can see this given omega is 0 because it is stopping. And then what is omega naught? Omega naught, if you can remember, it is 12,000 pi, and then plus alpha, and then t is 3 minutes. Then we can solve for alpha. Now alpha, it will be a negative value. Negative value because it is a deceleration. It is not acceleration, deceleration. So there will be negative value. Or from the beginning you can use here some negative value at the beginning. Then you will get here a positive value. That doesn't matter, whatever you use, both are fine. So make sure that you understood the concept. So if I go to the problem, whatever I used here, let us see what I did. Say yes, omega t equals omega naught alpha t minus t naught. T naught is 0 because we are starting from the reference point is 0. So this is 0, this is omega naught alpha t. After solving we got this number, and this time your unit will be radian per minute square because it is similar to acceleration, that is distance by second or distance by time square. As it is linear, so distance will be in radian and time will be in minute. So okay, we saw this example. In our next video we will do another example.